now we're going to do question 2. 2.1 says that we are given a sequence of 7xy minus 11, which is said to be an arithmetic sequence. So we are asked to determine the value of x and y. We're having 7x, y, and minus 11, and we are told that this is an arithmetic sequence. We are asked to identify the value of x and y, right? So for us to do that, we must use the constant difference to really get to find the values of x and y. So the constant difference says that, so before I write, let me just label my terms. This is term number 1, term number 2, term number 3, and term number 4. So the constant difference says that we're going to subtract term number 2 to term number 1, being equals to term number 3 minus term number 2, which is equals to term number 4 minus term number 3, right? So term number 2 is x minus 7, and then it's going to be y minus x, being equals to minus 11 minus y, right? So you're just going to equate our equations of the constant difference, right? So we will have x minus 7 is equals to y minus x, and then if we transpose the x to the other side, we have 2x equals 2, and transpose the minus 7, we have 7 plus y, right? And I equate this to equation 1, and then we will use this portion here and say y minus x is equals to minus 11 minus y, right? And then I transpose the y to the other side, I have minus x being equals to minus 11 minus y, which is minus x being equals to minus 11 minus 2y. Then I divide by negative 1, I have x being equals to 11 plus 2y. So this would be my equation 2. So I'm going to substitute equation 2. So I'm going to substitute equation 2 into equation 1. So whenever I see x, I'm going to put 11 plus 2y. So it's going to be 2 into 11 plus 2y is equal to 7 plus y, and then I multiply the 2 inside the bracket. I have 22 plus 4y is equal to 7 plus y. Transpose the y to the other side and the 22 to the other side. I have 4y minus y is equals to minus 22 plus 7. And so it's going to be 3y is equals to minus 15. Divide by 3 both sides. I have y being equals to minus 5. So this is the solution of y, which is minus 5. To find the value of x, you will say x is equals to 11 plus 2. So I'm using this equation into minus 5, which is your y. So x is equals to 11 minus 10, and x is equals to 1. So this is the value of x. We're going to do 2.2, which says that given the quadratic number pattern of minus 3, 6, 27, and 60, 2.2.1 says that determine the general term of the pattern in the form of Tn is equals to an squared plus bn plus c. So we are asked to find the general term of this quadratic number pattern. So we're having minus 3, 6, 27, and 60, right? And so the first thing you're going to do is find the difference of this. So this is the first difference, so it's going to be 9, 21, and 33. So this is the first difference. And then we find the second difference, which will give you 12. So this is the second difference. So 2a is equals to the second difference, which is 12. So divide by 2 both sides. Your a value is equals to 6. so it's just going to be 6, right? And then 3a, so your a value is equals to 6, and then 3a plus b is equals to the first term of the first difference, right? So which is equals to 9. This is the first term of the first difference, but we know that our a value is equals to 6, so it's going to be 3 into 6 plus b, which is equals to 9. And then we transpose this to the other side, we have b is equals to 9 minus 3 times 6, right? So our b value is going to be minus 9. And our a value, so it's a plus b plus c, is equals to the first term of the sequence. So the first term is minus 3, right? So I'm just going to write minus 3 here. But we know that our a value is equals to 6, our b value is equals to minus 9. So to find c, we're just going to substitute. So it's going to be 6 minus 9 plus c is equals to minus 3, right? So you should get your c value being equals to 0. Then the general term of this, therefore the general term of the sequence, which is written as therefore the general term of the sequence is equals to Tn being equals to an squared plus bn plus c. And to substitute the values that we found, a value is equals to 6, so it's going to be 6n squared, and b is minus 9, so it's minus 9n, and c is 0. So this would be your general term of the sequence. So 2.2.2 says that calculate the value of the 50th term of the pattern. So we have our Tn being equals to 6n squared minus 9n, right? And we are asked to find t of 50, which is 6 into 50 squared minus 9 into 50. So the answer that you're supposed to get if you punch your calculator, it's 14550, 14,550. 2.2.3 show that the sum of the first n first differences of this pattern can be written as Sn being equals to 6n squared plus 3n. So we must just write the sum of the n first differences of the pattern, right? And show that it's going to give us this value. So what this means is we need to remember that the first difference of the sequence, which was found to be 21, the first difference of the sequence is 9, 21, and 33, right? And you need to note that the first difference of a quadratic number pattern is actually an arithmetic sequence, right? So we need to identify the sum of this arithmetic sequence, where the difference between these two terms is just going to give you 12, right? So it means now that d is equals to 12, our a value is equals to 9. So we can find the sum. The sum is equals to n over 2 into 2a plus into n minus 1 multiplied by d, right? So we're just going to substitute. So it's going to be n over 2 into 2, our a value is 9, plus into n minus 1, our d value is 12, right? So it's going to be n over 2 into 2 times 9 is equals to 18, and then 12 times this n here, so it's going to be plus 12n, and then 12 times this minus 1 is going to be minus 12. We close the bracket, and then we're gonna have n over 2 into this 12n here, so it's going to be 12n, and then we say 18 minus 12, we're going to get 6, and then we're gonna multiply this n over 2 inside the brackets, and the final answer that you need to get, okay, before I say the final answer, it's going to be n over 2 times 12n plus n over 2 times 6, right? So this 2 will divide from 12, then you get 6, and then n times n, it's n squared, and then this 2 will divide, and 6 you get 3, so it's going to be plus 3n. So this is the sum of n terms, so it's definitely equals to the one that we are given. Now we're going to do 2.2.4, which says that how many consecutive first differences were added to the first term? How many consecutive first differences? Remember, the first differences we found in the previous question, it was Sn, right? So here we're just gonna write Sn. How many Sn were added to the first term? So first term, it's T1 of the quadratic number pattern to obtain a term in the quadratic number pattern of the value of 21,060. So what this means is the following. So it means now that how many sum were added to the first term of the quadratic number pattern, giving us 21060, right? And we found the sum in the previous question to be 6n squared plus 3n, right? And the first term of the quadratic number pattern, it's minus 3, right? It's minus 3 being equals to 21060. So this minus 3, you can just check it. It's this one here of our quadratic number pattern, right? So what you're going to do is just add and subtract everything. So we're going to transpose this to the other side. So you have 6n squared plus 3n minus 3 minus 21060 being equals to 0, right? So the whole point here is to identify the n term, right? So it's going to be 6n squared plus 3n minus 21063 being equals to 0. And then we can use the quadratic formula, which is x being equals to minus b plus or minus root of b squared minus 4ac divided by 2a, right? Where our a value is equals to 6, our d value is equals to 3, our c value is equals to minus 21063, right? Let me write this 3 properly. 6, 3, right? So we'll substitute into the equation. So it's going to be x being equals to minus, our b value is 3. Sorry, this is supposed to be b is equals to 3. So our b is 3, and then plus or minus the root of 3 squared minus 4, our a value is 6, and our c value is minus 21063, close bracket. Then you divide by 2 into our a is 6. So the x value that we're supposed to get is 59, or x equals to minus 59.5, right? Remember that it's not necessarily x, but it's n. N is equals to 59, or n is equals to minus 59.5, of which the number of terms can never be minus 59.5. A negative can never be a negative, so we'll take this answer here, which is n being equals to 59. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.